So I'm going to start here by opening up a new file. So File, New File, we'll click a Python file, and I'll just put a comment up here. I'll say TCP server side, and I'm going to save this. So I'm going to go to File, Save As. Of course, you can hit Control S to save, and I'm going to save it in my dedicated directory, which was on my desktop, and inside my folder Python socket examples, I'm going to create another directory. So new folder, and we'll just call this one. We'll call it socket intro. And the reason why we're going to have subdirectories here is we're going to have a lot of different projects where we have a server.py script and then a client.py script, and we want them to only correspond to each other. So we're going to save this one inside of this subdirectory, and I'll just call it simply I'll call it TCP_server. Okay, so perfect. So now that that's saved here, the next thing I'm going to do is, I think it might just help you all, depending on the device that you're watching. I'm going to go to File, Preferences, and Settings, and I'm going to up the font size here. I have it set to 14 right now. Why don't I bring it up to 20? It might just make things seem a little bit bigger, and I wanted to show you that in case you were interested in increasing your font size as well. Okay, so the first thing that we're going to have to do is we're going to have to import the socket module, which comes predefined or pre-installed here in Python. So I'm going to just use an import statement, and I'll import socket. So now with the socket module loaded, we can create a brand new socket. And since this is going to be the server side, I'm going to name my socket server socket, as it's going to serve as the server in my communication channel. Essentially, the thing that is always going to be listening for incoming connections. Now, so let me name that. I'll name it server socket. Now, when we name or when we create our server-side socket, we have to be specific with what internet protocol and what communication protocol we're going to be using. So we said for our purposes, we're going to be using IPv4 and mostly TCP. We'll do a little bit of UDP coming up here in the future. So to do that, there's a specific way that we can name those things here in Python. So IPv4 is going to be referenced as Address Family INET, or essentially AFINET, and then TCP is going to be referenced as SockStream. So I'm going to put a comment here. I just think it's going to help us in the future. I'm going to say create a server-side socket using IPv4, and that is going to be AF_INET and TCP, and that is going to be sock_stream. All right, so let's see how we do this. So we've named our socket server socket. To create this socket, I'm going to call the socket module, and then I'm going to call the socket method. And so that's going to create our socket. So here I'm calling the module that we just imported, and here I'm calling the socket method. Now inside of here, I have to pass that information. What internet protocol we're going to use? We're going to use IPv4. So I'm going to call socket.AFINET. So there's our IPv4 internet protocol, and now I have to pass in TCP protocol. So I'll do socket.sock_stream. All right, perfect. And so that is going to create our socket for us. So now that our server socket is created, we have to do something very important here. Since this is our server side, essentially the thing that is always going to be listening for incoming connections, we have to bind or essentially attach our socket to a given location, a specific location where the socket should be listening for incoming connections. Now, this location has to be given as a tuple with two pieces of information, the IP address and then the port address of that desired location. So we want our IP address to essentially be the IP address of our current machine. And so we could just look it up. So like if I open up a PowerShell here, and I think in Windows it's ipconfig. Yeah, ipconfig, perfect. So if you look down here, here's my IPv4 address, 192.168.1.7. And I could just hard code that in as the IP address. But the problem is if I go to a new, let's say a new Wi-Fi network, or maybe my router is going to assign new IPs if I shut my computer down, that can change. And so we don't really want to hard code that in, but instead we want to get the IP address dynamically using the sockets module. So let's see how we might actually do that. So I'll put a comment here and we'll say, see how to get IP address dynamically, rather than hard coding it. And so we're going to do this a couple of different ways. So we're going to print some information to the screen here. First, I can get the host name of my machine by calling socket.getHostName. All right, and I'll put a little comment here that this is going to be my host name. And so if I run this now, what we should see is the name of my machine. And the name of my machine is Spectre TAC Airmo. So Spectre is the brand of the HP laptop I have. I have an HP Spectre laptop, and then Airmo is my last name. So now that I have this host name, using that host name, I can get the IP address of that specific host name. So to do that, and we'll print this to the screen just to verify it, I'm going to use socket.getHostByName. So we're going to get the host that has a specific name. What name? Well, we're going to get the name by calling socket.getHostName. So we're kind of having, these two methods nested inside of each other. And so this is going to give us, Spectre TAC Airmo, and then we're going to get the IP address of the computer that has the host name Spectre.airmo or Spectre TAC Airmo. So I'll say IP of the given host name. And so let's see if we run this now. Do we get our IP address? And we get it right here, 192.168.1.7. So if my IP address were to change, I don't have to come back in here and then, adjust the code accordingly. Perfect. So now that we have our IP address, we just have to pick a port address to run the server on. And so I'll choose like a high numbered port to ensure that there isn't something already running on the chosen port. Most lowered ports are reserved for well-known services or programs. So I'll use just an arbitrary port. I'll do 12345. All right. So let's set this up. So we're going to put a comment here. We'll say bind our new socket to a tuple, and that tuple is going to be IP address and port address. All right, so we'll call our socket, server socket, and then we will call the .bind method. And so this is what's going to essentially attach it to a specific location where it's always going to be listening for incoming connections. Inside of here, I need to pass this as a tuple, so I'll need another set of parentheses. The first thing that I'll do is I'll give the IP address, and we're going to get that IP address just like we talked about before, socket.getHostByName. And then by what name? Well, we're going to call socket.getHostName to get the name of the computer, and then we'll get the IP address of that name. And so now I'm just going to come outside of the parentheses right here, and I'll put a comma because now I need to specify my selected port address. And we said for this, we're just going to arbitrarily choose 1, 2, 3, 4, 5. Awesome. So our server side socket is now created, and it's bound to a specific location. The last thing that we have to do is we have to tell it that it should listen for incoming connections, right? So like we created the socket, we sent the socket to a specific location. The last thing that we have to do is say, hey, you should be listening for incoming connections. So we'll just put a little comment here. We'll say put the socket into listening mode to listen for any possible connections. And so to do that, we just simply call our server socket, the socket we named, and we'll call the .listen method on that server socket. Perfect. So if I run this right now, hopefully we won't get any errors. Nope, so no errors here, so that tells me that this socket is essentially listening, but you can see the program just stopped, so we're going to need to add more to this to make sure that our server socket is continuously listening. But I think this is a good place to stop for right now. I'm going to keep this file open, because we're going to add more to it, but in our next video, we're going to begin working on our client-side script. So I will see you then. Hello and welcome back. Now that our server is up and running, let's create a new file that will hold our client script. So I'm going to come over here, File, New File. We'll name it a Python file, and I'll hit Control-S to save. I'm in that same location, the directory socket intro that I was before, and I will call this TCP client. All right, and I'll just put a little comment here. It will just say TCP client side. The first thing that I have to do is import the socket module, so import socket, just like I did before. And so now what we'll do is we're going to create another socket, similar to what we did on our server side. So we're going to call this socket, we'll call it client socket. And we will then use the socket module to create the socket, so socket.socket, and we have to pass in the correct information here again. I'll put a little comment in here. I like to comment things, so I'm going to just say create a client-side IPv4 socket, and that's going to be using AF_INET and TCP, which is sock_stream. So let's pass in that information. So our client-side socket is going to be using IPv4, so socket.af_inet, comma, and TCP, so socket.sockstream. All right, perfect. So with our server, if we come back over here and look at our server socket, we had to essentially bind it or attach it to a given location and then tell it to listen at that given location. With our client, we don't really have to bind it or attach it to anything, to a specific location, and we definitely don't want it to just sit there and listen for incoming connections. Instead, what we want to do is we want to have our client socket go connect to some other already established socket, like a server socket, at a specified location. So here, what we'll use is the connect method. And so for our purposes, we have to tell the socket where it's going to connect. So we're going to need an IP address and a port address. And I'm running both the client and the server scripts on the same machine here. So I'm just going to use my local IP address again, which we know we can dynamically get using the socket module. So we'll say connect the socket to a server located at a given IP and port. All right, so we'll take our client socket, and I'm going to call the .connect method. And inside of here, I'm going to pass that information as a tuple. And so the first piece of information we're going to pass is our IP address. So we're going to do socket.getHost by name, and then we'll do socket.getHostName. All right, and that's going to get us our IP address, very similar to what we did over here on our server side. And then we'll just pass in our port. And so we're going to keep the same port number as well. So we'll do port 1, 2, 3, 4, 5. Awesome. So that's great. So this IP and port are where the server is waiting, listening, and it's the same IP and port that we're going to tell the client to go connect to. So this seems like it should work. But now, once the connection is made between the sockets, what exactly do we want to do? Well, we want to send some data, right? That's exactly what we want to do. We essentially want to be able to send data back and forth between these two sockets. So right now, our server is set to listen for an incoming connection. So I'm going to go back to my server-side script. So what is it supposed to do once it receives an incoming connection? Well, the first thing that we're going to do is we're going to try to get the information about that incoming connection. And so we're going to start, if you notice, if I run my server script, it runs and then it stops. So we don't want that to happen. We want it to listen continuously or infinitely while connections are trying to be made. And so we're going to do that. I'll do that with an infinite while loop. So I'll say here, I'll put a little comment. We'll just say listen forever to accept. And right now we'll say accept any incoming connection. Any connection. So we'll say while true. And now let's take a look at what's going to happen here. So when a connection is made through our client socket, we want the server to accept or allow that connection. And so we can do that with the accept method. Now, this method returns two pieces of information. It returns a socket object, or the socket that was used to make the connection, our client socket, and it returns the address of the incoming connection. So let's grab those two pieces of information, and then we'll use some print statements to maybe print that out so we can see what's happening here. So we'll just say inside of here, we'll say accept every single connection and store two pieces of information. All right, so we're going to get the client socket. So we're going to get a socket object, hopefully, and then we'll get the client address from here. And so we want to accept our incoming connection. So I'll call my socket server socket, and we'll call the .accept method. So when our client socket tries to connect to our server socket, we will accept it, and we're going to get two pieces of information. We're going to get information about the socket that was just connected, and then about that address. So let's use some print statements here to print some information. So I'll say print, and we'll call the type function. I want to see what type of object the client socket variable is that we just grabbed here from the accept method, and then we'll actually print that information. So we'll say print client socket, and then we'll do the similar thing to the client address. So we'll call the type function and pass in client address. And this might just help us in the future as we're trying to write more complicated programs. It's good to know what we are getting from these from this accept method. And so then we'll print client address. Okay, awesome. Let's also maybe print a message to our server. So on the server side's terminal, letting us know that someone has connected to our socket. So we'll say print, and I'll use an F string here, and we'll just say connected to, and then we'll pass in the client address that we connected with. So we'll pass in client address, and then I'll just put maybe an exclamation point, and then a new line character, so it breaks it up. So now, if we think about this, what we're going to do, let's run this. Let's see how this works. So here is my server. It's running. Okay, so now we are in our infinite while loop. You can see that the program hasn't ended. And so now if I run my client script, hopefully we will actually connect here. And so we'll start another instance. No errors on this side. Program is still running. And if we go back, we can see, perfect. So if we look here, we can see that we printed out the type of the client socket. So it is a socket object, and there is that socket object right there. So this is the client socket that we connected to. You can see that af.inet, sock stream, all that stuff. Here is the IP address that we are connecting to, and the port address. Awesome. And then we're printing out the address that we got, which is a tuple, which is what we expect, and that's 192.168.1.7, our local address. And then if you notice, that port number 502 277 is not the port number that we had specified in our client script, right? We specified 12345. Well, 12345 is the port address we want to connect to, and this is the port address that the client is using for that connection. All right, so the client isn't going to connect at that port. It's going to this socket is running at this arbitrary port number of 50277. But we get our nice connected to, and we get our information. So everything here is working out really nicely so far. Perfect. So I'm going to just I'll stop the process here, all right, and close these out. And the last thing that we'll do here in this video, so now that we have made the connection, let's have the server, once it gets a connection, actually send some information over to the client. So we have the information about the client socket that we just connected to, right? So it's stored right here, client socket. So we'll take that socket that we just grabbed and we'll call the .send method on it. And so let's send a string. We'll say you are connected. So let's put a new comment here. We'll say send a message to the client that just connected. And so we'll call the client socket, which is the socket that we grabbed when we accepted the connection, and we'll call .send. So we want to send information back to that client socket. And so I don't know, I'll pass in the string you are connected. And so perfect. So let's try running this now and let's see what happens. So if I click run, all right, I'll click run over here on my client to get the connection. And if we look, we get an error. And so our error here is on the line where we're trying to send our information. It says a bytes-like object is required, not a string. And so this is really important here. So we can't just send strings through our sockets, our line of communication. What we have to do is we have to encode it and send it as a bytes object. So strings and other pieces of data have to be encoded with a specific encoding method in order to enter the data stream between our two socket channels here. Which, you know, it really isn't a problem because there's a method, a string method we can use to do that. We can call .encode on our string. So if we come over here, I'll type in, so here's our string you are connected, and then I'll type .encode, and typically what we'll do is we'll pass in an encoder. I think the encoder we'll use is UTF-8, so UTF-TAC-8. I think that is the default encoder, so you could leave that out, but I like to specify it because maybe we'll change that in the future. So now if we run this, hopefully we won't get that error. We'll be able to send that information just fine. So we'll run. And if I come back here, we can see that there was no error. So that data is being sent without any issues. Of course, now that data is being sent over to the client, but we got to do something with that client script in order to actually display the information. However, I think this is a great place to stop here in this video. In our next video, what we'll do is we'll wrap up sending data between these two sockets and finish it up here with the TCP communication. So I will see you in that next video. Hello and welcome back. Now that we are sending data on our server side, right, we're sending this encoded message, you are connected, and we're going to encode it as a bytes object. Let's go and receive it on the client side. So I'm going to come over to my client script, and we'll say, I'll put a new comment here. After the connection is made, we'll say receive a message from the server, and we'll also just claim here when we do that, so we can use the receive method. And when we use the receive, RECV method, what we have to do is pass in the maximum number of bytes that the socket should expect to receive in one single message. So I'll add that here. I'll say you must specify the max number of bytes to receive. So we're going to create a variable. I'll call this variable message, and we'll take our socket, client socket, and we'll call the .receive here method. And inside of here, we have to pass in the maximum number of bytes that we're going to receive. And so right now, I am just going to pick a very, a large number here for just simple text communication. I'll do 1024. All right, and that's not going to be an issue at all here. But you may be asking yourself, well, what happens if we try to send something larger than 1024? And I'm just going to say for now, it won't be a problem. But later on, when say we're creating like a multiplayer game and we're sending lots of information, it will become a problem. So at that point, we will address the issue by using fixed length headers that specify the size of whatever incoming packet is coming in. But for right now, we'll arbitrarily set this size to be 1024, and maybe we'll play with it a little while in a couple of videos, and we'll see the shortcomings of doing this. So let's test everything out and let's see if this works. Well, we should probably print the message, right? So we'll say print message. Otherwise, we won't know we got it. So I'll run the server. All right, perfect. I'll run the client, and hopefully we will send that information and then we'll print it. And you can see it did sort of print it. And it says you are connected, and it's got this weird like B in front of it. And that's because if we actually print, let's print the type, we'll call the type function on message, what we'll see is it's not actually a string. I don't think it's a string. Oh, I got to stop. Yeah, that's right. So I just got an error. It says only one usage of each socket address is normally permitted. I was trying to run the server again without stopping the previous one that I had run. So you can only run this once, right? So now that's running, and if I run it again, let's take a look. So here's our message, you are connected, but it's not a string object, it's actually a bytes object. So recall that if we go over to our server here, we had to encode the string and turn it into a bytes object to send it over our data stream. And so now once we got it on the client side, what we should typically do is we should decode it on the client end. And so we can do that by using the decode method for strings. So message, here is the message, and I will just say message.decode, and then I'm going to pass in the same encoder that we used on the client side. So I'll pass in UTF-8. Again, I think this is the default one, but I still like to print it in there. So I'll delete this, and if we run this now, hopefully we should see that we're getting a string object. Oh, and I made the same mistake I did before. Let me stop the previous instance and run my server. All right, so there's that. We'll run this here. And so you can see we now have a string object. You are connected. Awesome. So this is working out great. I think it's good practice to maybe just talk about closing our socket connections once our communication is done. So the last thing that I'll do here is I will close the client socket. And so this is on my client script. And I'll just say client socket.close. And maybe I'll go back over and do something similar here. I don't think I need to print the the type. Oh, I got rid of that there, so that's good. So I'll save this, and I'll come back over here, and let's close the server socket as well. So I'll maybe just come down here and say close the connection, and so we'll say server socket dot close. All right, and if I run this, what's interestingly, I think we're going to get an error. Let's just quickly discuss why we're getting an error. Oh, I keep doing that. I got to stop this. There we go. I'll run this. All right, I'll run this. Sends the information, you are connected. That is closed. Great. And if we come over here, let's look at the output. We do get an error, and the reason why we get this error is we are closing the socket, but we are still stuck inside of this infinite while loop, and so the socket which we just closed is now trying to accept a new incoming connection. So it can't do that. That's like an issue, right? So one of the things that we can do is once we close the socket here, we'll just use a break statement to break out of the infinite while loop. The last thing that I'm going to do is just clean this up a little bit. I'll put some comments here. So we're not printing out our host name and IP address, and I don't really need to print these things out anymore. However, I will leave them in there just for like debugging purposes, okay? So if we run this, everything should be good. There's our server. All right, nothing's happening. We'll run this. There's our client. It says you are connected, and if we look at our server, it says we have been connected to 192.168.1.7 at port 5427. What a weird way to read a number. 50427, 50,427. Awesome. So everything is working really great here. We got a nice basic TCP server and TCP client using our sockets module. I think this is a great place to stop, and I will see you in the next video. Hello and welcome back. In our last video, we set up a very simple client-server relationship using a TCP socket. Important things to note here. On the server side, we created a socket and then listened for incoming connections. We created the socket, we bound it to a specific location, and then we listened for our connections. And then on the client side, we actually had to go and connect to that established socket. And then once our connection was established, we simply called the send and receive methods to send data back and forth. Now, we're going to be using TCP sockets for all of our projects in these videos, but for completion, I wanted to quickly show a UDP client-server socket relationship. So recall, UDP is a connectionless protocol, so no connection will be made. Data is just simply going to be sent and received. So I'm going to start by creating two new files. So I'll do file, new file, we'll make it a Python file, and I'll make a second one, file, new file, I'll make it a Python file. Oh, I guess I should save it first. So I'll save this first one in our sockets intro. I'll call this UDP server. All right, and then file, new file, and we'll call this one, we'll save it as UDP client. All right, perfect. So now that I've got those two files here, let's start on our server side. So I'll just put a comment here. I'll say UDP server side, and we'll import the socket module just like we have done in the past. Okay, so now on the server side, I'm going to create a server socket, and it's going to use IPv4 and then UDP instead of TCP protocol. So I'll put a comment, we'll say create a server-side socket that uses AF INET, socket, well, IPv4. Yep. All right, and we'll then say and UDP. So instead of sock stream here, which is how we reference TCP protocol, we'll use sock underscore dgram, all right, for UDP, datagram. So let's create this socket. So we'll say server socket is equal to, I'll call my socket module dot socket, and now inside of here we have to pass in those two pieces of information. So it's going to follow IPv4 protocol socket.af underscore inet, and it is going to be UDP, so socket dot sock dgram. All right, perfect. So now that we have our server socket, what I'm going to do is I will bind it or attach it to a given location, just like we did with our TCP socket. So we'll say bind our new socket to a tuple that is going to be IP address and port address. All right, so we'll call our socket server socket, and we'll call the bind method. And inside of here, we're going to pass a tuple. We'll pass in our local IP address, and we know how we get that. I'm going to do socket.getHostByName, and that's going to give us our IP address of a specific host name, and we're going to get the host name by calling socket.getHostName. And I'll choose an arbitrary port number. Again, I'll use 1, 2, 3, 4, 5. Awesome. So now we've created our UDP server socket, and we have it bound to a specific location. Now, in our TCP server, if you look, the next thing that we did is we put it into listening mode to listen for our possible incoming connections. However, we do not have to listen for any incoming connections here because UDP is a connectionless protocol. Instead, I'm just going to sit around and, I guess, wait to receive some information from a client that has sent information to this specific IP and port address. So I'm going to actually put a comment here. I'll say we are not listening or accepting connections since UDP is a connectionless protocol. That's just there for, you know, my I think my understanding and hopefully your understanding. So we're just going to wait to receive some information. So rather than use the receive method like we did to get information here on the TCP client, we used the .send, and then our client used the .receive. We have to use the receive from method when working with UDP. So I'm going to come back over to my UDP server, and we'll use the receive from method. And this is going to return the data that was sent, like maybe a message, as well as the address information that it came from. So I'm going to grab both of these pieces of information, and grabbing the address here is going to then allow me to maybe send some information back. Because remember, no connection was made, so I need to know where this information is going to be going. So I'll create two variables here. I'll create message and address, and we'll set it equal to our server socket dot, instead of receive, we're going to say receive from. And again, inside of here, I have to specify the maximum size byte of the object that I'm going to receive, and we'll just arbitrarily say 1024 right here. All right, perfect. And so now let's go through and actually print this information. So we'll print the message. Of course, we know that this message, when we get it, is going to be a bytes object, so I want to decode it. So I'll say .decode, and I'll pass in UTF-8 as my encoder here. And then let's also print, for the purpose of this, let's also print the address. Okay, awesome. I think this looks good. Now let's head over to the client side. So I'm going to save this, Control-S to save, and let's head over to our client side and see what we're going to do here. So we'll put a comment here. We'll say UDP client side, and we'll import socket. And on the client side, we're going to make a UDP socket. So we'll say create a UDP IPv4 socket, and so we'll say client socket is equal to socket.socket, and inside of here I want to pass in the right information, so I'm going to use socket.af_inet, there's IPv4, and then we'll do socket.sock_dgram, and so now there is my UDP socket all created. Perfect. So now that we have this, let's simply send some information to our server, right? We've got this client. Let's send some information to our server. Now, if we look over here, when we use TCP, we used the send method. That was all we needed, right? Because we already had a connection made. We were just sending information through this connection. But UDP is connectionless, so we don't necessarily have a connection, a place to send this information. So what we have to do is we have to specify where we are going to send our information here. So let's say you will say send some information via a connectionless protocol. protocol. So we're going to, instead of using the send method, we'll use the send to method. Just like we used receive from instead of receive, we have to use send to instead of send. So I'll say client socket.send to, and then what do I want to send? I'm going to send the string hello, I don't know, hello server world, and we know that we have to encode this string, so dot encode, and we'll pass in our encoder UTF-8. And now I need to specify where exactly I'm supposed to send this. So I'm going to send it to a specific location, an IP address, and so we're going to use our local address. So socket.getHostByName, socket.getHostName, and then a specified port address, and we're using 12345. So I'm not actually making the connection, I'm just sending that information there to that desired location. Okay, so I think this looks pretty good so far. And so if we run this right now, let me save this. I will run my server. So we're expecting to receive a message. So here's my UDP server, no problem. And if I run this, here's my client. We should hopefully make a connection, and if I come back over to my server, it says hello server world. So the message was received, and then we are printing information about that connection. So it looks like our UDP, server client socket is working nicely here. Connectionless, right? It is connectionless. Perfect. So I think this is a good place to stop here in this video. In our next video, maybe we're going to mess around with our buffer size. So we've specified that the maximum size we should expect to receive is 1024, and let's talk about what that means if we change it for both the UDP and the TCP server and client relationships. So I'll see you in that next video. Hello and welcome back. Now that we have completed really basic TCP connections and UDP connections, let's play around a little bit with the buffer size. This maximum size we kind of arbitrarily sent to 1024 bytes for our message packets. And let's mess around with it for both the UDP and the TCP sockets and see how they handle them. So we'll start with our TCP socket. So with TCP, if I try to send something that is larger than the buffer size, the message is going to go through. It is guaranteed to get there. However, you might not get the whole message at once, but it's ensured that the message will get to its location. So to show this, let's open up our client side TCP, and right here where we are receiving our message, I'm going to copy this code where we're getting the message and then I'm printing it, copy it, and I will paste it in here. So we're going to receive it twice here. And then let's also change the buffer size from 1024. Let's just change it down to 10 bytes. Okay, perfect. So let's look at our server. So I'm going to save this. Let's go over to our server. And if we look at the server side here, we are still sending one message to our client. It says you are connected. So let's now run this. On the client side, we're going to receive it, but we're saying our maximum size can only be 10. So let's see what happens here. So if I run this, all right, and now I run my client. Interesting, right? So you can see we're getting our entire message. We received the first 10 bytes, you are co, and if we look, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then in our second message, we're getting the rest of it, nected, okay? So we did in fact get it. In our first receive call right here, we get the first 10 bytes, and then in the second receive call, we get the rest of our message, even though our server only sent one message. It sort of is stored in guarantees that the information is going to get there. We just have to pull it from the data stream. So that's how it's going to work with our TCP. And so I'm going to actually just quickly go back and change this. So I'm going to get rid of the second message here, and I'm going to change this back to 1024 and save that so we don't mess up any of those changes. So now let's look at the UDP side. So I'm going to come over here to where are we receiving? So we're receiving our message right here. So let's receive this, and I'm going to change this to 10. Okay, perfect. And so, we know that this isn't going to be enough, right? Hello server world is going to be more than 10 bytes. So maybe I want to run this a couple of times. So I'm going to, copy this. I'll copy the whole thing. And we'll paste it down here. So let's run our server and see what happens. All right, so our server is running. Let's run our client. We're sending the information. And if you notice here, nothing happens. The packet is simply dropped. We get an error. It says a message sent on the datagram socket was larger than the internal message buffer or some other network limit. Or the buffer used to receive the datagram was smaller than the datagram itself. So interesting, right? It doesn't work. So to quickly recap, TCP is a connection-based protocol that essentially guarantees that our packets are going to be delivered. They might not be delivered all at once, depending on what the buffer size is, but the information will be in the data stream and we can pull it down at a later time. UDP, on the other hand, is a connectionless protocol that does not guarantee that packets are delivered. And so, here in this case there was an error, and so the packets just dropped. You're not gonna get any of that information. Now that has its pros, it has its cons. Because of this, UDP typically is faster, and that's if you're working with data that's constantly being updated and being sent. Maybe you don't really care that we dropped a packet because an updated one is going to be coming, right after it. Maybe things like a video call, right? UDP is something that's going to be desired. However, for what we're going to be doing moving forward, we're going to be using our TCP connections. So I'm going to just change my UDP buffer size here back to 1024. And one of the things that we'll do in the future is we'll talk about how we might handle changing this buffer size so that it's dynamic, so that we can determine how big the packets are that are going to be coming in and set our buffer size accordingly. But that's something that we're going to be doing. It's a little bit more advanced, and we'll be doing it later on in these videos. So for right now, I think this is a great place to stop. We have a nice overview of TCP sockets, UDP sockets, and we're going to start diving further into those TCP connections starting in our next video. So I will see you then.